To graph a rational function, we have to find the y-intercept, the x-intercept, vertical asymptote, horizontal asymptote, and with some equations, a slant asymptote. A slant asymptote occurs when the polynomial in the numerator is a higher degree than the polynomial in the denominator. We'll be using this equation for example. Since the polynomial in the numerator is a higher degree than the denominator, we know we have a slant asymptote. To find the slant asymptote, we must divide the numerator by the denominator. We can use long division to do that. In this equation, we use synthetic division. As a result, we get y equals x plus 1. Now we graph the slant asymptote. The y-intercept is at 1, and the slope is positive, meaning it will go up. Next, we'll be graphing a rational function. We'll be using this equation as our example. First, we'll be finding the x-intercept. We set the numerator equal to 0. In this case, 3 does not equal 0, so there is no x. Next, we find the y-intercept. In order to find the y-intercept, we have to plug in 0 to our equation. As a result, we get negative 3 over 2. We went ahead and plugged in more numbers into the equation to find more plots. Next, we find the vertical asymptote. We set the denominator equal to 0 and solve. As a result, we get x equals positive 2. Now we mark the vertical asymptote with a dotted line on the graph. Since the first degree polynomial is less than the second degree polynomial, the x-axis is the horizontal asymptote. Now we plot all the information we've gathered onto the graph.